Last class, we have seen the general electronic configuration, how to calculate electronic configuration, and how many electrons can accommodate in each shells. That is given by the formula 2n square. So, in today's class, we will see how to draw an atom by giving its electronic configuration or number of electrons. So in today's class, we are going to discuss about how to draw the structure of atom using number of electrons. For example, it's given that magnesium atom having 12 electrons. How will you distribute these 12 electrons, or they may ask how to draw the structure of magnesium atom. How can we draw this? How can we draw the shells? So we'll see. So 12 electrons. So there are 12 electrons. We know each shell can accommodate 2n square electrons. So first we will distribute electrons, these 12 electrons in each shell. So we know first shell is K shell, second shell is L shell, third shell is M shell, and N shell also there. So in K shell, we know K shell is the first shell. So how many electrons can accommodate? 2 into 1 square, that is 2. L shell, 2 into 2 square. 2 square is equal to 4 into 2, 8. So if we distribute, we'll draw that one. For drawing shells, first we have to draw around, this is nucleus of an atom. Nucleus contain protons and neutrons. And we'll draw the first shell. So we know in K shell 2 electrons can accommodate. So 2. So from this 12 electron we have given 2 electrons to K shell. So how many electrons left there? 12 minus 2, that is 10 electron. From this 10 electron, 8 electrons are accommodated in which shell? 8 electrons are accommodated in L shell. So we'll draw L shell and we can distribute 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So from this 10 electron we have distributed 8 electrons. So how many electrons left? 10 minus 8. So 2 electrons more left. So these 2 electrons can given to M shell. So there will be one more shell, that is M shell. So we'll draw one more shell, M shell, and we can distribute this 2 electron. Like this manner, if we get number of electrons, any atom, any shell we can draw. So totally if we count 2, 2 plus 8, 10, 10 plus 2, 12. So we have distributed 12 electrons of magnesium. This will be the general structure of magnesium atom. In the nucleus, protons and neutrons are there. So the first shell is K shell. Don't forget to mark the shells. So first one is K, second one is L, third shell is M. Like this manner you have to draw any atom. Or else we'll see one more thing, that is atomic number. What do we mean by atomic number? Atomic number is the number of electron or number of protons. It is number of electron or number of proton. In the examination, they may ask, draw the structure of sodium atom. Draw the structure of sodium atom. We should know the atomic number of sodium. may be given atomic number of sodium of 11. And how we can draw? So 11, its atomic number is 11. So that means total number of electrons are 11. So it's contain 11 electrons and 11 protons. So we can draw. How we will draw? First we will draw a small nucleus and mark 11 proton. Then we'll draw shell. First shell. So first we have to identify the distribution 2n square. K shell, how many electrons? 2 into 1 square. 2 electrons. So 11 minus 2, 9. So 9 electrons are left. So mark 2 electrons in the K shell. Next shell is L shell. L shell. So from 9 electrons, how many electrons can accommodate in L shell? 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So from 9 electrons, 8 electrons are distributed. How many electrons left? 1 electron. So 1 electron will be accommodated in which shell? The third shell, that is M shell. 1 electron. So this is the general structure of sodium atom. Okay. If atomic number given, you have to identify the atomic number is none other than number of electrons. So don't be confused. You have to draw like this. So like this method, you can draw any atom. Then we'll see very important property of atom, that is valency. Valency. We have discussed about valency in last chapter also. What do you mean by valency? Valency can define as the combining capacity. Valency is known as the combining capacity. In simple words, we can say valency is the combining capacity of an atom. In last chapter, from the last chapter, we know that atoms are unstable. Only few atoms are stable. For example, helium, argon, krypton, etc. There we have said some atoms are stable, monoatomic, like that we have studied. How can we say an atom is stable? If we draw the general structure of any atom, if there are 8 electrons in the valence shell. Valence shell means the last shell. For this one, K shell, L shell, M shell. So this is K, L, M. So here valence shell, that is the last shell, that is known as valence shell. Valence shell contain 8 electrons. If it is contain 8 electrons, then we can say an atom is stable. Or else, in the case of helium, we'll take the example of helium atom. Helium's atomic number is 2, hence it's contain 2 electrons. So how can we draw the structure of helium? It's small nucleus and shell. So 2 electrons. So only 2 electrons. So K shell already 2 electrons should be given. So 2. So it's having only one shell, that is K shell. It is filled 2. Maximum 2 electrons can accommodate in K shell. So it is already filled. So we can say that helium atom is stable. If any atom contain, if for example helium, only in the case of helium, the stable number of electrons is 2. All other elements should contain 8 electrons in the valence shell. Then only we can say an atom is stable. If an atom contains 8 electrons in the valence shell, we can call it as stable. If atoms not having 8 electrons in the valence shell, they are unstable. So we have seen the example of sodium, magnesium, etc. Chlorine. We'll see with chlorine. Chlorine's atomic number is 7. So what will be its electronic configuration? That is 2n square KLM. We will write like this. In the first shell, K shell, 2 electrons. So totally 17 electrons are there. So 2 electrons in the K shell. So 17 minus 2, 15 electrons are there. So L shell, how many electrons can accommodate? 2 into 2 square, that is 2 square is 4 into 2, 8. So 15 minus 8. So here 8 electrons. Then how many electrons are left? 15 minus 8, 7. So in M shell, again 8 electrons can accommodate. Totally in M shell, 2 into n square. N square is equal to 3 square. So 2 into 3 square, 9, 18. M shell can accommodate 18 electrons, but it will actually occupy only 8 electrons. Why? Because if there are 18 electrons, there will be so much repulsion between these electrons, so it will collapse. So hence, M shell also carry 8 electrons, but in the case of chlorine, only 7 electrons are left there. So M shell 7 electrons. If someone asks you, write the electronic configuration of chlorine with atomic number 17, you have to write like this. Generally, you can write like this. Chlorine 17, electronic configuration is 287. If we add this one, 8 plus 2, 10, 10 plus 7, 17. You will get this configuration, this atomic number. Then our answer is correct. So 287. So how can we distribute this one? How can we draw the structure of chlorine? How many shells are there? 1, 2, 3. 3 shells are there. Center nucleus is there. So mark the electrons. Either you can mark like this cross, or you can mark like this dot structure. Both methods are correct. So second shell 8 electrons, third shell 7. So 7 electrons. So in this, which is the valence shell here? K shell, L shell, M shell. So the valence shell is M shell. M shell contains 7 electrons. Is it stable? No. If there are 8 electrons, then only an atom will be stable. So here only 7 electrons. So what it will do? What it can do to attain stability?